Hey guys, welcome to 1.4 Lists Part 2. So we're going to start this lesson with looking at a whole pile of extra methods, stuff that's really useful for changing lists and getting quick results, like adding and subtracting certain elements. First one we're going to look at is the pop method. So I got this list here. Good pets is equal to dogs, birds, and cats. So clearly this is wrong. Let's fix it. We can obliterate this last element here, cats, with the pop method, which gets rid of our the last element in a list, which in this case is cats. So let's type this in our terminal, and we'll do this together. So type good pets equals, or you can just copy and paste that line over there, but only take a moment to type it as well. All right, there we go. Good pets is equal dog, birds, and cats. And if you type a list, right, it'll show you the list in the terminal. It's like printing it in your code. All right, now if we type good pets.pop and with an empty brackets set there, of course, because this is a method, then it will get rid of this last element, and it also evaluates, and in other words, it returns the element that was popped, which in this case is cats. So if we type this again, you'll see now we have dogs and birds. And now we have a better list of good pets. Okay, what's next? Well, the pop method also removes the list element at index x, which is -1 by default. Now, -1, if you remember, index -1 means the last item in a list, right? That would be cats over here, because it's the farthest to the right, the last one. And it returns it. So we could also get rid of dogs if we typed good pets and then .pop and type in an index in like 0, right? And then what that would do is get rid of the first one. So all we're left with now is birds. But there's an even easier way to get rid of an element at an index. And really, if you don't need this return value that pop gives you, you can just use the del statement. Literally, you just type del space and then your list and then the index you want, right? And this will delete whatever is there. Okay, so let's go back here for a moment and we'll copy and paste this. We want to get good pets back. There we go. And now we've got the original list back to normal. Now we could type del good pets, and now we could type in our index -1. Right, and that would get rid of the element at the end, cats. So this is another way of doing it that is quite straightforward. Okay, so now let's look at the remove method. So the remove method is fundamentally different than pop because it removes the element x rather than the element at index x. So if we type something in these brackets, all right, like dogs or birds or cats, then it will get rid of the first instance of that element in the list. Okay, so let's do an example again. So we'll again set good pets to all three of these guys. Here we go. And then we'll type good pets dot remove, and now we can literally type the string cats. And notice how it didn't return anything, but if we type good pets, then we'll see that it got rid of the first time it found cats, right? Now, let's just for a moment put that back in. Good pets dot append and cats. And then we'll do that again. So now we can see that we should have two of them, right? Dogs, birds, cats, cats. So if we now type good pets dot remove cats, what it's going to do is take the first one out. That's this one, because it's the very first one that it's going to find in the list, right? Good pets. You can see we only have one left. By the way, to bring up a previous command in the terminal, press the up arrow. That's what I'm doing here. And then down lets you cycle back, right? So you can look through all the commands you've recently typed. And this is a shortcut to typing it all out again. So let's remove cats again. And now we only have dogs and birds. Now watch what happens if we type remove cats, right? So this time, because there was no cats in the list anymore, it threw an error, a value error, and list.remove x not in list, right? So it says, hey, I couldn't find cats anymore. Here's a value error. You're welcome, right? So make sure that if you use this function, this remove function, which is handy because you can type exactly what you want removed right in the bracket, right? This could be a variable, could be an integer, whatever you want. But if you do use this, make sure that you're actually removing something that's in the list. Okay, and a good way to do that is to use a condition like this, right? You could type if x, whatever x contains, in goodpets, then goodpets.remove x, right? So if x contained the string cats, then it would remove cats, right? So just tuck it into a condition like this, and then you won't risk crashing your program. Also just note here that I have a little mistake. This colon should be up on the condition, right? Okay, now let's say that we wanted to determine where a particular item was in the list. Find, or in other words, find its index. So we could use the index method, right? So index, just like remove, accepts an element as a parameter. So it could be a string, it could be an integer, it could be a Boolean value, anything really. But let's say we wanted to know where birds was. So we could type goodpets.index birds, right? And if we do that, let's check and see what's in here. Then we should get this index, which would be 1. So if we type goodpets.index and now type the string birds, then we'll get index 1. Okay? And now this, one thing to note here is that this only returns the location of the first instance of the element, all right? And it throws an error if it's not in the list at all, right? So if we typed goodpets.index, snake, then it would get, we'd get a value error just like before. So again, right, you have to make sure you're looking for the index of something that's actually there, okay? So, and also if the list has 2 different copies of the element, it's only going to give you the first one. So there are 3 standard, very popular list methods that you can use to manipulate your lists. And there's a whole pile more here at this link, which I'll show you for a moment. If you open this up, you get to Quackit, which has some great tutorials and stuff here, but also a nice kind of collection of methods with a description and examples that are all quite visual and pop out very well. So some of these, by the way, you'll need some extra methods when you do your project for this section. So you could look at this later to figure out how to, say, count the number of items in the list or how to sort them, etc. Okay, what we're going to talk next about is list references. So recall from our first unit that variables store a value. Each is like a box that contains something, right? Like an integer, float, or string. And all of these boxes are contained in the current scope or frame, which resides in RAM, right? So let's just look at this for a moment using the visualizer, and you can right-click this and go to a new window, and this is our little visualizer that shows us some of this stuff, right? So here's a little program that has some variables. So if we set x to 5, then we'll see that pop up in the global frame. X contains 5, right? Y is now going to contain x plus 3, and when you have an assignment statement like this, right, it's going to go back, figure out what x is, add the 3 to it, and then store that in y. So of course that's going to be 8. Right, now if we set x to 0, right, then it's going to change what's inside the box for x, right, which changed it to 0. But notice how y did not change, even though we defined y as x plus 3, right? And that's because this was evaluated, right, at the time of assignment. So x was 5 at that time, and so y contained 8. And then it doesn't matter that you change x later, right? So if we print both of these, we're going to see 0 and 8 in that order. Now there's a fundamental difference in how lists work, okay? So we're going to look at this next. We'll just close this. And I want you to see what happens when we try this one, which we're also going to open in the visualizer. So just, load this with me as well, and you can step through it. Pause the program if you need to, if I'm going too quickly. So here we have, a list with 3 elements assigned to x, and then we're going to assign y to x. Now I want you to see how this is different, right? So first of all, we see in our global frame that x now, notice how before x contained the number 5 and it was inside this little box, right? But now x contains this pointer. You see this pointer? Which means that there's an object created. Lists are actually objects, they are more complicated. It's a more complicated type of data. It's not like an integer or a string or a Boolean, which goes straight into the box. Okay, an object exists separately from the variable. It exists out in RAM, and when you assign, okay, the value, when you assign a variable to an object, it literally just points to the object. Okay, this is a kind of a complicated idea, but I think it might make a little more sense as we step through. So now for step 2, we're going to create y and set that to x. So watch what happens. So now we have y in the global frame, and it was assigned to x, but x already points here, and so therefore y also points there. In other words, right, x contained a pointer, and so now y contains that same pointer to this object over here. Okay, so now if we print x and y, we should see what both of them refer to, which is this list, right? So if we print them, then here we go. We have the same list printed twice, right? Now if we change, first of all, the first element of y, right, which we know x also refers to the same list, then what do you think is going to happen? Well, we're going to change this this 1 to swag, right? And we'll see that now this list, right, to which y refers and x has this different element at index 0, which is swag. So now if we print x comma y, both of these refer to this same list, and therefore now we have, we have the updated list in both cases. Even though, this is the big idea here, guys, right? Even though all we did was change the first element of y, right? The key here is that y doesn't contain something different than x. They both refer to the same object. And so a list is called a mutable object, which means that it can be changed in many different ways by methods and by changing any variables to which the list refers. Now I just want to show you one quick thing here before we move on, just to show you how you could change this behavior if you actually wanted y, okay, to refer to a new list, right? What you could do, well, let's edit this for a minute, is you could type x.copy, and this is a list method that we're going to learn later. But let's do this. So add .copy to the end of x here. And what this is going to do is return a copy of the list of list x and assign that to y. Let's click the visualizer again and watch what happens now. So we set x to 1, 2, 3, right? And then we're going to set y to a copy of x. And so now y points to a new list, right? A brand new one. And so when we print them both, they look the same because they are, they're the same initially. But if we change the first element now of y, then you're going to see that only this list changed because it's different, right? It's not the same list anymore. So when we print them both, now only the second one has the updated element at index 0. Okay, so hopefully this drives it home, right? That if you don't have this copy, if you assign a list to another list, then you're referring to the same list. And this is a big deal because when you're passing a list to a function, which is what we're going to look at next, it means that you're really passing a reference to a list, and you can then work with that list in the function. So let's now go back to the lesson, and we'll look at that. So passing lists to functions. So this is like I said, the same thing happens when you pass a list to a function. You're not passing, you're actually passing a list, a new list. You're actually passing a reference, right? So the parameter that references the list in the function contains a reference to the original list object that was created and can be used to read or change the list object within the function. And this, of course, means that we don't technically have to return it because we're modifying the list which already exists in the global frame. All right, and so what I want you to do is look at this function here that I've created. And we're going to visualize this one too. So just open this with me here. I've got this in the visualizer. And what I've got here is this function called bug squisher. And it accepts one parameter, which is a list type parameter. And this is not documented, but I'll just explain it so that you understand. And then for every bug in the list, okay, it's going to check if the bug is in one of these. In other words, if it's one of these things, right, then we're going to remove that thing, right? So, so of course, not all of these things that we're going to pass in are going to be bugs. There's going to be a couple other things, cats, dogs, whatever. But the way this function works is it goes through each thing in blist and checks if it's in one of these, or if it's a bug, basically. And if it is, then it removes. We use the remove method here to get rid of it. Okay, so let's step through this together. So if we go through the program, of course, it's going to define the function. So there it goes. Now we have our function. But then we're going to get our list created. Right, so here's our list, my list, which contains 6 things. And a few of these are bugs that we're going to see up here. And now we're going to call Bug Squisher and pass it this reference to my list. Okay, so you can see here that we're now inside our function. We've gone up to our function, and the parameter blist is pointing, right? Is pointing to the same list that we defined as my list, right? So as we go into the function, we can now work with blist because it refers to this list, the same one that's my list, right? And so now as we go through, we're going to go through for each thing in blist, right? We're going to get bug. It now contains cat. That's the first one. And we're going to check if cat is in our list of bugs, right? Which of course it's not. So it's going to go back up and check the next one. And now we have dog. And dog is also not in this list. So we're going to get the next one. And then of course tree is also not there. But eventually we get this one, beetle. Right, so that's the third. That's this guy here at element 3 or at index 3, right? And now that's going to be found, right? Because now bug is in this list, which is right there, right? So now we're going to go. This is going to be true, and the function will remove, right? It'll remove beetle, and there it goes, right? It's gone. And then we're going to keep going through, and then it finds wasp, right, which is at the end as well, and it's going to remove that wasp. You should see that disappear, right? There we go, and then we're almost done here, right? That was the last thing in the list, and so finally the function ends, and we end up here, and we can print my list, which does print what remains after the bugs were squished by our bug squisher function, right? So so our function, right, accepted the list as a parameter and then looped through it and removed any of these things that it found inside the list. Let's go ahead and grab this text, because you can actually select it from here. Actually, click Edit the Code and select it from there. And we're going to copy that and paste that into our note as our first example. We'll call this example 1. Oops, let's close this. Example 1, passing a list to a function. And then we'll paste that in there. And now we'll be ready for our next example. So I want to show you one more thing before we move on here. There's another link here I've got. Just right click this, open this up, this visualizer. And I want to show you what happens if you reassign, okay, the variable that's passed in to a new list. See this statement here, line 5? I said blist is equal to goat. I just assigned it to a new list. So watch what happens. So this time it's going to go through, right? It's going to give us my list, and then it's going to go up, start squishing the bugs. And it's going to find cat. It's not going to be there, right? It's going to keep going until it finds one. And eventually, when we get to beetle, it's going to get inside. It's going to remove beetle. But then, here's the big thing, right? So it's going to set blist, which we know already refers to this list, to a new list, right? Now, but the problem is that this is currently pointing to our old list that we defined out here, right? So watch what happens. Okay, so what happens is instead of overwriting the old list, right? Do you see what happened? It created a new list and reassigned the parameter to that new list. Okay, and so this can be a bit confusing, but the big idea here is, okay, don't reassign a list parameter within the function. You can use any other things. You can use remove or index or delete. You can change values of the list. You can take them out, put new ones in as much as you want. You can modify the list, but don't reassign it, or else you're going to lose access to it, right? Because if we kept going now, right? If we keep going, then watch what'll happen, right? It's going to check now if goat, right, is in this list, and of course now we've just killed it, and it's going to give us a value error because blist now does not actually contain the proper list anymore. So this is a big idea to keep in mind. Okay, so one thing I want to finish with is just one more modification to this program to kind of show you something else we can do. This time what we're going to do is reassign an element, and we're going to insert actually an element and replace each bug with sloth. So let's again go to our visualizer and see how I've changed this. This time line 5 says blist.removeBug, but just before it I'm going to use blist.insert, and we're going to do, remember this insert, right? You can use it to specify what index you want to insert something at, and then what you want to insert. So insert is a method that allows you to do this. It's a new one. So it accepts two parameters: where you want to put it and what do you want to put in. Okay, so let's step through. So this time we get all our same stuff, right? And once we get to a bug that's in the list, which is beetle, right? Now it's found it, and it's going to go inside. And this time we're going to insert at the index of beetle, right? Because that's what this would evaluate to. We're going to insert sloth. So you'll see here at index 3, watch. Now we have sloth, right? It pushed all the rest of them to the right. This is what insert does, right? It adds an element and pushes everything from that point forward to the right and increases those elements. And then we'll remove beetle, right? And so what this does in effect is kind of replace beetle with sloth, right? Because it adds it at that same index, but then removes it directly next. All right, and so fox isn't there, but wasp is, and so again we're gonna put a sloth in there, right? Right before wasp, and then remove wasp, and then the function concludes and prints. And now instead of beetle and wasp, we have sloth and sloth. So this is how you can work with a list in a function, right? When you create functions to work with lists, feel free to use any of these methods in it, and you don't even have to return it because you've passed a reference to the list, and you can do whatever you like within your functions. Okay, so at this point you can now go ahead and complete Replit Assignment 1.4 A to C, and once you're done that, you can begin Project 2. Be sure to read this carefully, Project 2. All the requirements, right? These are big deals, and they require careful attention and strict submission processes. Good luck, and we'll see you guys later.